Hello, you are welcome. In this video, you will learn how to set out the grid lines for this steel warehouse. We also learn how to carry out the modeling of the different structural elements of the steel warehouse. We load the warehouse and then we will carry out analysis and design of the foundation successfully in this video. As you can see, the steel trusses right there is being carried by the reinforced concrete columns successfully. So this is what we're going to be doing. Stay connected and then let's make progress. So here we have the architectural plans of the steel of the warehouse. So we'll come over to the sections AA right here. So if you check the section, you will notice over here we have the roof level at office area. Okay, so if you check the plan, this side of the plan is the office area. Okay, and this is the main workshop area. Alright, so the sections is explaining that the roof level at office area is at this point. Okay, you have a total of 6 meters. Okay, so 3.17 meters thereabout is the roof level of the office area. Okay, so this has explained what you are supposed to do. Alright, so this takes us to the plan itself. So from the plan to set out the grid lines successfully. Okay, so after setting out the grid lines, we now have to make sure we have the columns being set out successfully. All of these are layers. Okay, so you have to create a layer through the layer property. Alright, just like this, and then give it a name. You can create a new layer using this icon, and then once you click and give it a name as columns, just as we have it existing here. Okay, and as well the grid line successfully. So after which you have to just proceed to make sure that you place them at the center of the walls. Okay, and as well as the column. So while this is done, you have to select it all, just like this, and then you press W on the keyboard and enter. So you have this right block windows. So click in these 3 dotted provisions, and then you'll be able to give it a name and then save it as DSF, because Protastructure actually understand and read DSF file and not DWG. Alright, so once you save it, you have it in your directory. Okay, so after which we have it saved successfully, you can now proceed to Protastructure. Okay, so in Protastructure, here we go. So we have to create a new project. Okay, I've already worked on this, so we proceed to the file type right there and then click on new project. In the new project, you can give it a name as workshop 2 right there, and then the code of practice we have to be using is going to be United Kingdom. Okay, BS8110 code. Okay, there are other codes here. This is Protastructure 2022 version. Okay, so if you want to use a code from an existing project you've done, you can just click on these projects. So this is going to show an existing project. Okay, which if you select any of the projects simply means you are using that particular code in that project. So we select the templates right there, click on OK. So this is going to create an United Kingdom BS8110 template, which we are going to be using for the modeling, loading analysis and design of the steel workshop successfully. So we proceed to the DSF import. So click right there. So this will open a DSF import windows where we click on this DSF, the load DSF provisions. So this takes us to the directory. So in this directory, we can navigate to where we have the DSF file saved successfully. So here is the DSF file, this one, select it, open it. So give it some time to load successfully. Okay, so that has been loaded successfully. So if you notice, this has actually read the grid. Okay, read the columns, read the walls and the beam. So we wouldn't need beam, we wouldn't need walls. Okay, we only need the grid lines and columns successfully. So after which you have to now be able to import the right options right here. So what we imported is plan. So if you are importing a 3D physical model, you have to select it here successfully, so that you can be able to import it successfully into the program. Alright, so after we click on import, so once you click on import, you give it some time for import to be completed successfully. So once the import is completed successfully, you just have to click on the close right here. How will you know that import is completed? Because the provision where you have import tab here will be faint. Okay, so that means it is successful. So you click on closed. Alright, so we see we have the columns, and then we also have the grid lines being imported successfully. But in this, you notice the grid lines are not properly or orderly numbered successfully. Okay, so the vertical numbering is supposed to be alphabetically, and then the horizontal is supposed to be alphabetically, while the vertical is supposed to be numerical. So it all depends on how you want it to be done, but you can get it selected just like this, and then you can be able to edit these grid lines successfully. So in this houses table, we have 13. Now 13, we can take that to be A, so it's going to be in capital letter. Okay, so 16 is going to be B right there. Okay, and then you have 15 to be C. Okay, and 14 is going to be D, and here we have E. Okay, so click on close. Alright, so the same thing is applicable to this other side. Okay, but for the sake of time, let's make progress. Okay, so now we have created this successfully. Let's start to place the reinforced concrete beams at first. Okay, so we go to the modeling tab. Before that, I have to save the project. So having saved the project successfully, you click on the beam icon right there. So in the beam dialog, you will have to set the beams width to 5, and then the beam depth is going to be 450. Alright, so just like this. So we can now start to place the beams successfully. So you can do a window over a particular provisions to have it placed successfully. There are various ways of drawings a beam members. So this is the first method. Okay, so you can now pick the first columns, take all the way to the last one, and picked also to have it placed just like that. Okay, so you can only right click to get rid of the command. So also do a window over this provision and click, you have it placed just like that. Okay, just like this. Okay, those are the two ways you can be able to place the first concrete beams successfully. So after we must have done that successfully, we proceed to the 3D. So we see what we've done so far. So if we check the AutoCAD file right there, you will notice that the total height has been given to us as to be 6 meters. Okay, so this 6 meters is the headroom. So you can see where it stops. Is the headroom where we have the ceilings. So that means we have an additional 655 millimeters. Okay, which takes the structure to the leveling where we have the roofing structures. Okay, but this we are going to be taking the first roof, which is the office area roof, to be 3.6 right there, and then from the office area provisions to the leveling, okay, it's going to be taken as 3 meters. So together we'll be having 6.6 meters. which is the total height of this workshop building. Okay, so let's proceed. All right, so at default, Protastructure do have a 3 meters 3 meters first floor level at default. Okay, so let's go into the settings to make sure that we are on the same page. So you click here, right click, or you can come to the building setup here and then come to stories operations. So here you can get to edit stories, okay, and make ordinary editing successfully. So select on the stories, right click and click on edit stories. So in this edit story dialog, we want this story to be 3.6, but before then, let's proceed to the foundations. We wanted these foundations to be 1,200, okay, millimeters foundations depth, okay. Then the first story bottom level is going to be 600, okay. I will show you what this is, okay, in a minute. First stories bottom level. Click on OK for now. Yes, options. To show you what the first story bottom level is, I will take you to AutoCAD, okay. So you click on these AutoCAD provisions, and then these sections will explain much better. Okay, the first story bottom level is the 600 you are seeing here. Okay, all right. We normally call these provisions to be DPC, which is the normal floor level of the warehouse. Okay, this is concrete work right there. Reinforced concrete slab right there. Okay, for the first story is bottom level. Okay, so the distance from the normal ground level to that level is the 600, which is the first story bottom level you are seeing in Protastructure successfully. So we have made all the necessary adjustment to that. All right, so the next thing we will be looking at is to insert stories. We only have story 1. We need to have more stories, so you select insert stories right there. So we have here to be 2, okay, so we click on OK. Alright, so now we have this other story 2 right there. So we need to generate these stories, okay, successfully. So we are not generating all, okay. This aspect, the side of this office area is going to be lower than the main workshop area. So we have to select the area we want to actually generate. Okay, so we are generating this to the next level. Okay, so what we need to do is having selected that, come to the stories and stories operations, and then click on generate stories. Okay, so once in these provisions, you see selected members only. Okay, so this is the source story and this one is the target story. So select the target story, which is story 2, click on OK to have all of that being moved, okay, to the next story 2. Okay, so click on the OK options. Alright, so this is what we supposed to have. Okay, what that section is telling us is this. Okay, so now we proceed to the edit story, so we can make an adjustment in the story height of the first story 1, which is 3.6 right there. Okay, so the 3.6 right there. So the total what we are having is 7.2. 7.2 is because of the 600 of the first story bottom level. Okay, because of this one. Okay, all right. So we may progress. Click on the OK options. So now we have this. What we now need to do is we need to introduce some columns. One more column. So move the gray line to the level 1. We need the columns here. Okay, because we are using steel trusses and we really want to rest or sit the trusses on the reinforced concrete beam directly. It should be on top of the reinforced concrete columns. Alright, so for us to do that, select this column, right click and then click on the property, and then once it is activated, just like this, you have to just move closely and then be able to place it correctly at the green line intersections to have that placed successfully, just like this. So I haven't placed this beam is not going to be valid again. You have to redraw this beam, so delete this beam, and then you can use the property of these other beams, okay, pick this point and then all the way here on this point. Okay, so after which you right click to get rid of the command, and then over to this side, select this, click on delete. Okay, so use the property by selecting the beam, right click and then hit property to be able to place it again. Alright, so it is going to be a continuous beam. It's not supposed to be a single or simply supported beam, because there is a reinforced concrete support columns at the center successfully. So this is how it's supposed to be. Okay, so after which we will now be looking at working on the beams in terms of the beams depth. Okay, so at these provisions where we have the workshop, these beams, I will hold the control key to select multiple of it. I want to change the depth of it, okay, because it serves as a roof beam at this particular part of this structure. So you right click and click on the property, and then we have 450 height. So select in this edge provisions and click on the column wise edit. So in the column wise edit provisions, you type 300. I want the depth of the beam to be 300 right there. Okay, so the same thing applicable to the roofed beam of the main workshop. Okay, so that we can select in the structural 3 provisions. So go double click on the level 2 right there, and then expand the beams right there. Select the first one, you can hold the shift key, select the last one to have all selected. Okay, so after which you right click, and then once you click on the property right there, you can be able to now change this as well to 300 right there. Click on OK. Alright, and then close this. So having said that, we want to load the beams, because these beams are going to be, carrying wall loads. Okay, so we need to apply wall loads on these beams successfully. Okay, so to apply wall loads on these beams, what you have to do is to navigate to the loading provisions and then load cases and combination. First, you have to enable these load cases and combinations. Okay, so click on the loading generator. So give it some time to be able to boot up, just like this. After which we are dealing with concrete and steel structure, so you have to check these provisions. Okay, create different combinations for steel member design, because you are combining the 2 different materials. Okay, so after which come over, this structure is to be built in an exposed environment, so we have to activate a wind load, okay, combinations, which the wind speed in meter per second has been given successfully. We'll feed that in, and then I will take us to where we feed that in successfully. Click on the OK option. So we have the loading combination generated successfully, after which we click on the OK options and proceed to the load editor. Alright, so for the load editor, you can do it like this by selecting one of these member or the B members right here, after which you can right click, and then you can see in this drop down menu edit loads. Okay, or you can use these options right here. Okay, so click edit load. So let's edit the load that will be, the wall load that will be on this particular B members. Okay, so here is the wall load editor. Alright, so in this wall load editor, we will have to look at some important settings right there. So we are dealing with wall load, which is this one. Okay, so you can also click in this side to actually take it to 3D, or you can hold the left mouse button and then be able to turn it in a way you like. Okay, so we navigate to the wall load right there. So in the wall load editor right there, so we are dealing with a wall height of 3 meters. Okay, so the unit weight already is given here to be 2.4. This 2.4 is basically for 9 inches block, including per square meters. It's for 9 inches block. Alright, then when you add finishings and then partitions, you will now have it to be 3.47 right there. So this is what we are going to be considering, and then average load is going to be 10.41 kilonewton meters. Okay, so the height we are considering, okay, is going to be 3 meters. All right, so we proceed, and then you have to just select this beam to have it. So this has been placed successfully. Okay, so having placed this successfully, you want to see it, just click here, these provisions, to have it visible. So here is the wall load. Okay, this is just like a wall on this beam. Okay, so what if you have an opening elsewhere? What you will do? So what you need to do, if you have an opening, you click on the edit openings. So in the edit openings dialog, it depends on the locations. Like in this workshop, you will have an opening elsewhere around here. Okay, so what you need to just click on add right there. So you have a kind of a squared opening like a windows, but you cannot adjust it using these provisions. Okay, so let's say the height of this is let's take 700. Okay, this height right here is 700, and then the width is 2 meters. So we'll have something of this kind. So we need to now move it upward. So in the y directions, let's have it to be 2 meters right there. Okay, and then in the x directions, we need to balance it. Okay, by reducing the 700 maybe to 300 we are about. Okay, that is much. We have it to be 500. Okay, so let's go by 550 or 600 thereabout. Something of this kind is the type of window that we have over there. Click on the OK options. You see it is not active, so you just have to click on the update right there. Okay, to make it active. Click on OK options to insert it successfully. So now you see what we have, something of this kind. All right, so we are now going to copy this and then replicate it on these other provisions. So let's copy this. Let's copy this, and then you click on the copy. We have to select copied wall load. So you have to get the wall load selected first. Okay, before you now have to right click. Okay, so in the drop down menu, you see copy load. Okay, so you click on copy, it will show this dialog, copy load, click on OK, and then yes, options. So you can now select this, and then you can select it as well, and right click. When you say paste, right here, this has been pasted successfully. Okay, so if you want to get rid of the openings right here, right when we copied it, you can as well get rid of it. So over here we wouldn't have these openings. All right, so to delete it, you just have to use this option or delete load. So you click on OK to get rid of that. Then delete load. This is for the sake of learning. Okay, to get rid of that. Okay, so select this again, right click, and then click on copy load again. You have this, click on copy. It will ask you if you want to also paste the opening. You say no. So once you say no, select this and right click, paste again. Right there, see there is no openings now. Alright, so this is for the sake of learning. Okay, so we paste it here. So if you want to proceed with the openings, you want to select this one, right click. Okay, that's one thing that is good using a Prota Structure 2022. Okay, it's very effective. So you right click and click on copy. So we just pasted the one we copied from here, so it has covered these other ones right there. So let's see if we can undo that. Okay, so the undo button has actually undo that. Select this again, right click, and be able to copy this again. Click on OK, and then yes, options. We want to copy opening, so select the first beam with the control key, and then you can have a multiple of these beams selected. You see, mistakenly select the column, so click on it to deselect it, beam and beam right there. Okay, so you can also come over to this other directions to select the beams right there, just like this, deselect this grid lines, and then select this beam. So just have to paste it. Alright, so we have this. Okay, so select this again and paste, just like that. Okay, so this is how you be able to load the structure in terms of the wall load successfully. Okay, now we look at the steel trusses. Okay, for the steel trusses, we navigate to the modeling tab right there and then click on save to save this project as first. So select steel truss. We have to pick 2 points. Okay, so you pick the first point, which is this point, and then all the way to this other point. So the steel trusses dialog will come up, which is this one. So we are to be selecting the type of truss we used, which we are going to be looking at this type of truss, this one. Okay, so having picked that type of truss, what we will now proceed to do is to carry out the settings. So if we check the apex height is 2 meters right there. Okay, and then the left ear is 1000. So here we change it to 300. Okay, so we click in that provisions. All right, we navigate down to the right here right there, and then 300 again. Okay, so having set those provisions successfully, we will now proceed to the numbers of space. Okay, the number of space at the left and the number of space at the right. Okay, so we will be having 6 spaces. Okay, and then 6 right here. Okay, just like this. All right, so for the apex height, we will change that to 1500 right there, just like this. Okay, so we need to have some cantilever. Right, so left cantilever length we will make it 600, as well right cantilever length we will make it as well 600. Okay, so we have something of this kind. So we haven't this cantilever, we wouldn't have the left ear height again. So this will enable us to increase the head height right here from 300, let's say 400 thereabout, and see. Okay, we have some head height. Okay, that serves as our fascia. Okay, so we proceed to change this other side to 400 as well. Okay, that is the right head height. We have the right and left. These provisions supposed to be 400 as well. Okay, so we are good to go. At this point, we get to the member tab, so we can't be able to select the members. Okay, so in this kind of roofing, or the steel members is supposed to be single angle and not double angle. So what you see here at default is a double angle, and then the section is 100 by 100 by 10. Okay, so this can be changed if you click in these provisions. This will take you to the database of the materials, so you can see universal angle right there. This is an equal angle, and then if you check in these provisions, click on select right away, you notice this option is selected, which is back to back. Okay, so it's double. Alright, so but before you use a single angle, you use the click on these provisions to select a single angle. Okay, so this is how these provisions is being managed successfully. Okay, so after which you click on the OK options. I just want us to have a understanding on that. So click on OK again to have this truss being placed successfully, just like this. So you can now see what is there. Alright, so you continue to place the trusses right on top of the reinforced concrete columns. So we'll place that here. here and here. Okay, we also place a truss here. We are using it to obtain the cantilever there. Okay, so alright, so having placed the trusses successfully, we have to place the purlins. This is not properly placed, you have to lay that. Okay, so for the purlins, you will have to, let me get to the purlins right there, click on that, select the first truss, select the last one, and then give the program some seconds to bring up the purlins dialog. So here is the purlins. You can manage the spaces between the purlins. For now it is 1 meter spacing. Okay, the purlins you can manage it maybe 900, or you want it to be 1.2. and then the purlins profile, you can click here, you can use UPFC. Okay, click on OK. That can be changed as well. For the sag rods, we have two kind of sag rod, profile angle and the profile itself. Okay, so you can decide on which to use, and as well the diameters of the sag rod is 12 millimeters. The materials of the steel we are using is 279 the strength. So over in these provisions you can also be able to change to any strength. Okay, but 275 is economical, and then is easily seen in the market successfully. Click on OK to place the purlins just like this. One thing I didn't explain here is the cantilever by the purlins cantilever. So you can also add cantilever. If you don't click on this purlin, take you to this dialog. Okay, so you can see left cantilever length. If you want it to be 1 meters, and then right cantilever length, you can also key in 1 meters. Alright, so you see, if I zoom closely, you can see the cantilever I'm talking about. These provisions, click on OK. Alright, so after which you have this. Now for these other trusses, we will have to place the purlins successfully. So save this project, and then go back to the modeling tab, pick the purlins again, pick this truss, and then pick this one. Okay, this is not properly picked, so the whole thing got scattered. Okay, so click on cancel. Alright, so you have to deselect this particular one just like this before you proceed to pick this. Okay, and then make sure you move the green lines to the story 1. Double click to move the green lines down to the story 1 just like this. So you now pick the purlins, pick this and this. Okay, so we are still having this. The reason is because we were at story 2 placed this other truss. Okay, we placed the truss at story 2, so that is why we are having this scattering or irregular purlins. It is trying to connect, the purlins is trying to connect the higher story and the lower story. For instance, I click OK, you will now have something of this kind. You see the design. Okay, so this is just like a design as well. Okay, but this is not an intended design. Alright, so we make progress. If you want to get rid of that, what you just have to do is you just have to select this. Okay, if you select that, you can easily delete it right here. Okay, but then you need to get rid of these members. Okay, so get that deleted. So what that means is when you want to place your trusses, you need to move the green lines to the level in which you place your trusses, because if you placed your trusses on a green line lower than the level, okay, the active green line level, you are going to have that irregular purlins. Okay, so what do we do now? We proceed to trusses again. So we have to place this truss separately from this other one. So we are still considering is the same truss that we are set. Okay, so click on the OK options, and then you can pick the one at that point. All right, so having done that, you can now proceed to placing the purlins right away. So pick the purlins, this one and that one. You see we wouldn't have that problem we had last. Okay, so everything is good just like this. Okay, so we have this, but in this case we wouldn't need the cantilever, so you have to double click. So which of the side are we considering? Okay, it seems to be the left hand side. Let's try this and see. Click on it. Okay, so that is this side, so we wouldn't need this other right hand side. You provide 100 meters right there and change that provisions to 0. Click on OK. So we have something of this kind. So we proceed to the modeling tab, deselect the purlins, and then pick the clouding. So select. So we see this is the active grid line level, so I have to pick that point to have a clouding right there. So this clouding will actually help us to load this structure. Move the grid lines to level 2. Move the grid lines to level 2. Alright, so you proceed. You place the clouding. Okay. So after which, at this point, you have to load the structure. So we are at level 2. So we can now go to the loading slide there, save the project first, and then click on it. We have to click on the load editor. So once you click on that, this will load successfully. What you see here are the safe weight of the beams. Okay, so we want to load this. So for us to do that, let's use a filter so that we can be faster. So click in this position, select this, right click and filter it. Filter simply means it's going to be left alone, just like this. Okay, so here is the roof purlins and the clouding. Okay, so we use the full uniform area. So click on that full uniform area. So I will click on that. The magnitude of the load we'll be using is 0.1. So we key in 0.1. So you have to select all of these members and release your hand. So once you release your hand, you have to give it some time to boot. Okay, so you can now see it's being boot and then the load has been applied successfully. So basically, this type of load is the dead load. Over here you have the dead load and the live load, which is the G and the Q load. Alright, so for the sake of this lesson, this is being placed double on this, so you can now see the first one and the second load right there. Okay, so I will just take these two loads to be both loads successfully, okay, for the sake of time. Otherwise, having placed the dead load successfully, you have to select in these provisions and click the live load. So once you click in the live load, you notice there is no load here that acts as the live load. Okay, the only load that is acting is the G load, which is the dead load, and then the G load, as you can see right there, is times 2. Okay, it's because of the selection that we did that makes it to be times 2. But if you want to get rid of it, you can click in this right provision. So now have it in this phase, and so you can click right here to make sure you select the first one. So let me take you through that process. Okay, so you just have to get rid of these second provisions, second load here, right here. So after having it selected, okay, you can proceed to delete that up by using the keyboard, or you can right click and click on removed. Okay, so once you click on remove, you see it's gone. So we are now only having the dead load only in the one layers. Okay, so navigate to the live load right there. So you have to also click on the full uniform area load, and then you can now make changes to the load magnitude. All right, so we are having two. Right, so the same process, you have to select all the members right here and release your hand. Okay, so once you release your hand, you can give it some time to load successfully. So it's been loaded successfully. So the load is in 2 layers as well, so you can easily get back to the other side using the cube navigator, so you get right so that you will not overload the structure. So these loadings are depending on your own calculations. Okay, hold down the control key to be able to select multiple of the second layers of these loads, so after which you can be able to navigate back and then you right click and click on removed to have only one. Okay, so now having successfully loaded the roof, we click on the OK option. So once you click on the OK option, you see it's been applied successfully. So there are some version of this Protastructure that after you must have loaded this successfully, get back to the load editor again. So once you get back to the load to confirm that this structure is loaded, we still see the load right here. So navigate through the dead and the live load, you still notice that the load are intact, but there are some version, once you come back here, you notice the loads vanish. Okay, in that case, you are designing your structure without load. Okay, those versions are not original. Okay, so this one is a license version. Okay, so click on the OK options. Having loaded that, we need to load this other roof, so you have to navigate the grid lines to that level 1. Okay, at level 1, you click in the load editor to have this. Okay, so once you get this, what you just need to do is just the same thing, click in the clouding right there and then filter it out. All right, after which you get to the full uniform load right there. We'll be using 0.1 as well for the dead load right there. Okay, so select all of that, so you can see the load is being placed successfully. All right, so in this one we'll only work with the dead load. Okay, it is double, so the first layer will serve as the dead load and then the second layer we use it, make it serve as the live load right there. So click on the OK options. Okay, so after which everything is done, we now have to proceed to material setting. Okay, so we have to set the materials. So you go to the building set out and then over to this provision, see materials. Okay, so you click here. So in these provisions, we have concrete structures, reinforced concrete structures right there. So we need to change the strength. Okay, to we use this 320 and 625 concrete grade right there. So you have to screw down and then you have to apply this to all of the structure concrete members right there. So for the grade right there, we will be considering 410 right there. Okay, and then the reverse diameters, click in the provisions. Okay, so we will look at the columns right here. If you select here, we have only the columns other ones selected. So here you can now select between the rebars you actually wanted the program to use, between 16 diameters to 25 diameters successfully. So we have also the beams here. It's going to be between 16 to 25 diameters. We have the foundations here. The foundation is supposed to be 12 and 16, but 12 is not here, so uncheck here. So you can be able to select 12 in these provisions just like this. Okay, so over to the links, we will be considering 8 and 10. Alright, so you get rid of other links provisions or the shear reinforcement successfully. Alright, so this is how you select your reinforcement material. Click on OK options and then OK again, and then finally you have to OK. So after which you have to proceed to the analysis. Before then, save the project. Having saved the project, get to the analysis tab right there. Okay, then you navigate to the building analysis. So we are going to be considering static analysis. So we over here we can also look at the wheel load. I tell you, we have to do some settings on the wheel load. Okay, so click in this wing and story load, and then click in the wing load calculator provisions. So the wheel speed over here is 35. Sorry, is yes, 35 meter per second. So you put here 35 meter per second, and then you can leave all of this at default. Okay, and then the building categories is reinforced concrete building, so you just use composite. All right, so click on applied and then OK. So after which you can proceed to the setting centers. In the setting centers, here you can now be able to do some necessary settings like the foundations settings, and then you can also proceed the preferences. Okay, the preferences settings. Okay, which has to deal with your title blocks successfully. Okay, so for the foundations, you can come over to the provisions, expand these provisions, and then you can be able to make adjustment to the soil stress, the soil allowable soil stress. Okay, for the sake of these presentations, it takes 160 kilonewton per square meters. All right, so the minimum footing size can adjust it, and then the minimum base, the minimum part base depth, you can make adjustment here to 350. Okay, and as well the steel bar spacing. Okay, the maximum you can make it 200. Right, so these are subject to changes. All right, after which click on the OK option. All right, so having checked and set that successfully, get to the analysis tab. So we'll be running a building analysis, and then let's see what happens. So I want to show you something shortly. So click on the building analysis right there. So it will pop up this. Okay, so we wouldn't want to design all of this. We'll do the design later after analysis. So we'll have these provisions left unchecked. Click on building analysis. So let's observe the analysis being carried out successfully. So the analysis is still in progress. Video analysis is completed successfully. The multi-story draft satisfied the limit in both directions 1 and 2, and so click on the OK option. Alright, so now we are done with the building analysis. You have to close these provisions. Alright, so you now start to check the members to see if they have passed design successfully. So for the columns, select this and then click in the column, RC columns / wall design. So actually we have not designed this column, so now we want to design it. Okay, because it was not included in there. So now we want to design it, so click on the column design batch mode. So we select that, you can reselect all bars and click on calculate. So you can now give the program some second for it to carry out designs of the reinforced concrete columns. Okay, since analysis has been done, now we are now doing design. Alright, so click on the closed option, so you can now see we have all of the columns are past design except this one, column C1. So it's not an issue, so we can check that out and see the size of reinforcement being selected, reinforcement diameter being selected for all of these columns. Okay, some of these are quite really tough reinforcement, as you can see Y25 right there, diameters. Okay, because of the weight of the steel trusses. So that is designed successfully. click on closed. So for the steel truss, you can select one of these steel truss, right click, and then you click on steel member design options. So alright, so you can now see that this has not been designed as well. Okay, so you can click on check design right there, and then you can check all members. So it is now the steel members is designing. Okay, so the designing of the members is in progress. So we have altogether 32 of these members, steel truss members, both the top chord, the bottom chord, and the braces, vertical braces right there. Okay, so the design is successful. You can see over here the utilization ratio. Okay, that these members of these steel trusses are even much larger than we are supposed to. So you can now be able to proceed to make sure, instead of using a double angle, you can use single angle, because you can see your U ratio right there is 0.09, 0.01, less than 1. Okay, so the limit is 1, so this is far less than 1. Simply means you are over designing. Okay, with this we are over designing, so you can make it a single top and bottom chord for the trusses successfully, and everything as per design successfully over here. Okay, so click on the OK options. Alright, so we proceed to design the foundations of the structure. So we navigate to the story 0 to design the foundation of this structure. So right click and then enable story 0 right here. So here it is story 0. We can now proceed for the foundation design. So we want to design all of these columns at once. Okay, so designing it at once does not mean we can still be making our necessary changes. So just follow the process. So you right click and then click on the insert part footings. So in the insert part footing provisions, the dialog have to boot up just like this. So you have all of this. So these are the total numbers of columns we have. So we are going to be designing it. Okay, so we can design it one by one. You can design it all of it at once. Okay, so I prefer designing one by one, which means you can be able to select this one now, and then you click on the design selected. Use these options and not this option. This option is when you are designing for all, while this option is when you are designing the selected columns successfully. Okay, so you can click on design right there, because we selected this, so we want to design it separately. So having click on design, you can give the program some time to be able to boot up, and then check the columns load. So you see analysis results cannot be found in this particular one, so check this one. So when you have analysis results cannot be found, okay, simply means you will have to maybe carry out the designs, the analysis again. Okay, but analysis result is found in this one, so we proceed with this one. So for this particular column, we are having to be 1 by 1.2, make it 1.2 by 1.2, and then the depth is 350 right there, the footing depth. Alright, so you can check that in the 3D view, and then so you have this. Okay, so you notice this is double reinforced. Okay, so you can come to the rebar provisions and uncheck this. You want it to be single reinforced, just like this. Okay, so this is fine. You can click on back to geometry, and then after which you can click on the OK options right here. So we have designed this particular column successfully. Okay, so the same process we will use to design every other columns successfully. So using the same process, all of the foundation, the part footing that has been designed successfully, and so you can see the LS and the LY of it successfully. So click on the OK option, so to have it exacted just like this. Okay, so if you now navigate to the 3D of this, now see what you have right here. Okay, so we have been able to carry out this design successfully, Okay, so if you want to join our mentorship class, there's a link in the description of this video that will lead you to the mentorship class. Once you make just a small amount of money, and then we can be able to train you totally product structure successfully. If you have any question, drop it in the comment sections, and then we'll see in the next presentations. Okay, stay tuned, stay connected, and stay safe. Bye for now, and God bless.